Hello everyone, my name is Xipeng, and today I will introduce the a monolithic macro integrated circuit technology, and it's the review of the MMIC technology. So the first part is the MMIC technology overview, and I will show some introduction to the MMIC. And MMIC are integrated circuits that combine both active and passive components onto a single semiconductor substrate, and they are widely used in the high-frequency applications such as the mobile communication and the radar and the RF sensing. So the typical operating frequency of the MMIC ranges from the 1 GHz to over the 100 GHz, and supporting both analog and the mixed mode designs. So these circuits offer the high speed and the low power consumption and the compact size, making them ideal for the modern wireless system. And so for the RF and the microwave frequency range, and the microwave defined as the frequency above 1 GHz are used in communication, stateless, and the wireless. So various RF bands serve different applications. For instance, like the GSM and the operating around the 900 megahertz. So while Wi-Fi typically use the 2.4 and the 5.8 gigahertz. And so for the history of the historical development of the MMIC, it's mainly originated in the 1964 as tactical instrument. So several semiconductor material are used in the MMIC, and so each with unique properties. And here it's the time schedule about the MMIC's development. So the next part is the materials in the MMIC technology, and here is I show some material from the textbook, and we can see the 1, 2, 3, 4, 5, and the first is the gallium arsenide and the silicon germanium and the silicon carbide. So these materials and the choice of substrate depends on the required frequency and the power handling and the thermal performance and the cost. And and the next part is the active devices in the MMIC. And so we can see like this material, the GAAs, and it enables operation above 25 GHz with low noise, and is readily used in the mobile and another system, especially the silicon. The silicon it's always combined with this material, and they can make up the we can see this picture. They make the many layers, and they can make up the different device, and combined with the electric material, and they can have the many applications. And then it's this material HEMT, and it's the high electron mobility transistor. And so first, it's the principle of this substrate material, and it's similar to this material, and but incorporates to a this two-dimensional electric gas. This using the hyperstructures. So about this one, now onto active device like this HEITs or high electron mobility transistors, and they offer the low noise and the high gain, making them ideal for the low noise amplifiers. And like the metamorphy HEITs or the MATEs they extend the performance by enabling like the IMP like layers on this material substrate, so resulting in low cost and the larger wafer size. And then it's like this heater it's mixed by these two material, and the key advantage of this material its ability to handle high voltage, high temperature, and high power. They are all essential for the next generation RF amplifiers. And so like the piezoelectric and spontaneous polarization effects naturally generate the 2D EG even without the doppling, which simplifies the fabrication process. And so next one is like this triple V coupled HBT, and we can see this one, like the GAS HEITs have the high power density due to the vertical current flow, and also they suffer from the GAS materials poor thermal conductivity. So advanced of this material, it using the IMP or the INAIAS. Sorry, this material, the name is a little difficult to say. And without this one, provide even better performance, and are used in very high speed digital and analog circuit. And then next part is the combiner and the dividers. So next we move passive components, like the combiners merge multiple signal lines, and dividers split a signal into multiple paths. Like the signal, it's the normal way is only towards one direction, but like this one, it can get it towards to the different directions. It's the multiple paths. So they can be realized using the T junctions or directional couplers, and depending on the application. And the power dividers can offer equal or unequal output powers, and are key components in signal distribution networks. So that's the this part. And then it's the isolators and the circulators. So for the isolators, it allows the F signals to pass in one direction, while blocking reverse signals and using the magnetized ferrite material. And like the circulators direct the signals from the one port to the next port in the rotational path. And isolators are essentially circulators with the third port terminated, and the good, like the a good impedance matching at the third port is essential to achieve high isolation, often existing 20 dB with proper terminators. And we can see these two pictures. It's easy, like the example diagram for the circulators and the isolator. And the next part is it's the hose and the metal air bridge. So the VAR holes are vertical electrical connections between the different layers or sides of a chip. In the MMIC, they are etched through the GAAS substrate and filled with gold, and they are crucial in microstrip and core-plane waveguide structure to ground layers or provide signal paths. And however, reliability concerns such as the thermal stress and degraded capacity yield must be managed carefully. And for the metal air bridge, finally the air bridges are metallic structures that allow two transmission lines to cross without the electrical contact, and they are essential in dense MMIC layouts to route signals cleanly across intersecting paths, and fabricated using metal deposition technologies. And the air bridges maintain isolations and preserve the circuit integrated. Now we can see these two pictures. And for the first one, it's an ideal VAR hole in this material structure, and like this one, it's the metal air bridge, and also use like we can see here is this material substrate. And so that's all my presentation, and thank you for the watching, and bye bye.